Hi, I'm Kai and I'm happy to announce that MXAM 12.0 is now out. So as you see, no minor number, no bug fix number, so a pure major release of MXAM. And with this major release, we are introducing a new range computation feature, which computes the worst numerical range in order to detect arithmetic overflows, dead code, and design errors on the model level. So by that supporting ISO 26262 recommendation design principles of strong data typing and defensive implementation techniques. So let's have a quick look what guidelines are covered here. So such as the strong data typing of arithmetic blocks, and for instance also the division in Simulink. So yeah, this includes detecting errors that may also not be found by static code testing due to optimizations from the code generator. And this range computation improves, for instance, here the check for the guideline to avoid divisions by zero in Simulink. So because the former check more or less reported review findings on most of the divisions in the model, only considering specific patterns, modeling patterns, and this is now reduced thanks to the precise computation. So let's have a quick look here. So for instance, here we see the review findings of MXAM 11.0 versus 11.12. And which is now reduced thanks to the range computation, which gives you a more precise findings. So talking about precision, let's see, or let's have a look how you can configure this. So we have here this check for the overflow detection, and there's a parameter MES computed range precision, where you can choose between low, medium, and maximum. And this is now choosing like a trade-off between the precision of your computation, as well the reliability of your findings, and the check runtime. So let's have a look how this looks in practice. I had a check here of the overflow detection. So we see here that there is a data range of the output that is insufficient to cover possible results of run numerical operation. And this is here the app block. Let's have a look. Where is it? There we see that the range of the output cannot cover the whole range of this numerical operation. And as with every release, we as well increased our map coverage, which is now nearly complete. And therefore, we also broadened our scope of checks. So because we have now checks for guidelines that are about usable characters, for data type definitions such as enumerations and bus signals in embedded MATLAB code, and as well length restriction for these. And therefore, we have now checks that are analyzing these identifiers in embedded MATLAB code. So really a new scope for our checks analyzing the encode. So another small but great addition we have in this release is regarding the use case that we have ran an analysis overnight, for instance, on the CI server, and now want to resolve guideline violations locally. And in the of course the artifact have had another path on the CI server and different to the one locally. I think you can really connect to this use case, and now we want to run locally the guideline or resolve the guideline violations, and then we can open the one here. Now look, continue work mode, and now the import report functionality automatically detects that this model is on different paths, so we can open it here manually. And can proceed with working on the guideline violations. Another great addition in this major release of MXAM, the MXAM 12.0, is that it helps you on that we have an automated migration of projects. So I think because you as an engineer may relate to the point that manual migration with different error-prone steps is not really the way you want to spare your time with. So instead, really focus on working with MXAM. So this is why this major release helps you with migrating projects from later releases or from older releases. So let's have a look here that we want to load a project. This one, which is coming from an older release. So when we load this here, so you get some report what has been done here. So first of all, we see that the guideline document should be updated. We will have a look on this, and then that the project was aligned with the updated content, which is, for instance, that there are some selection of guidelines. So as you know, in or in between releases, so we always updating checks, adding checks, and for instance here for this guideline in one of the releases between the project, or what was between the project here, is that we added this check, which is then now automatically selected here because the guideline was selected in the project guidelines. Also interesting, we see here that one parameter setting has also been migrated, which was defined here for this check. And now, let's have a look what we can do further on this regarding the update document. So let's see here. So we have here the project guidelines, and now we can update this guideline document, which was one of the features of the 11.3. And now also with this major release, the MISRA SLSF 29 document is gone. So since this was old and is now deprecated, so since we have the updated or the latest document, which is MISRA AC SLSF 2023. So then we can now go ahead as usual and updating the stuff here so that we have also a document which complies to the updated content of MXAM. So as with most software tools, so as you know, in specific fields there are several software tools on the market, and this also is the case for static testing of models. But in order to ease the migration, talking about this topic again, we have added the feature that imports configurations directly from the tool of Model Advisor, really to smoothen the process in moving from Model Advisor to MXAM. And this is how you can do it. So by creating a new project, and here we see below the MXAM project, so there you can create a MXAM project from a Model Advisor project, and therefore you can go ahead here and choose the Model Advisor project that you can see here available as a JSON file, and therefore import this and convert this into an MXAM project. Another improvement of this major release is the handling of reusable elements and Simulink together with MXAM. So as a background, as you know, there are several reusable components available in Simulink depending on the use case. So we have the virtual subsystem, we have the block with the library link, and as well the references to a subsystem or a model respectively. And now with MXAM 12, there comes an improvement for this use case, which is that you can now repair elements that are in linked libraries. So let's have a look at this. So first of all, we have an addition in the report, so which you see here that we have now a reference path property and a reference name, so that you can really clearly see if this element is part of a subsystem with a library link. Now let's have a look here. We have here a finding and a constant, which is about that the show block name is set to off, which should be shown to yes. So we see here the link to the library, and the library is called gain-add. And with MXAM 12 you are now able to repair this. So let's do a quick split screen and repair both of the findings here. So we set show name to on, and also here's another indicator in the repair dialog is that this is in library gain-add, so that you clearly see that you are, or that you want to repair a element that is part of a library, which may, according to your process, maybe you're not allowed to, but really to see that you are repairing a library element here. So but for this use case or for this showcase, we want to also apply it here. And then we see it here in the findings per check. We see the both repairs, and we also see that we still have the findings for the gain and constant also for the other references of this library. And since we repaired them in the library, so we can just easy do a rerun here and would now expect that these both findings here are going to be removed, and see that with this one sweep of the repairing the library, so every instance is now repaired, and we resolved 6 findings of this guideline. So let's do it with another guideline. So we see here a finding as well for the gain block, which is about the rounding mode that we have set the floor rounding mode. The same goes for the sum. And as we already know it, that we have several instances in this model, which is here where we have one gain add, and as well here above other links to the same library. So we see that we have the finding for the gain and sum here, and as well the same finding here. So that means again to resolve the violations for the library. So let's put again these, or let's repair these both findings, setting the round methods to 0. We can just click apply all. Where we now see both are repaired, and we would now expect that these findings are also going to be passed after the rerun. Yeah, so this feature of repairing linked elements so really speeds up the process of automatically repair guideline violations with MXAM in such use cases when you using reusable components such as libraries.